Hopefully you just got done watching the video lesson on solving systems of equations by graphing, which is an excellent method to use when solving for x and y. However, sometimes we don't have graph paper. Sometimes it can be very cumbersome if the graph needs to go very, very large or very, very small. So substituting and eliminating is more so the method that is oftentimes used. So for this lesson, we're going to solve systems of equations by substitution. Now, the very first place that you have to start when you're substituting is you have to get a variable all by itself. It doesn't matter which one. It could be x, it could be y. If your variables are m and n, if your variables are j and k, it really doesn't matter what your variables are. Just make sure you get one of the variables all by itself. So for number 2, that was basically already done for us. This variable is all by itself. X equals a negative 2 minus 3y. We know what x equals, so x is already by itself. So we don't have to do that step in this problem. But there are going to be other problems in Excel math where you're going to have to isolate a variable or solve for that variable first. All right, so now when we're substituting, I guess one thing I kind of think of is I definitely have a love for sports, and when I think of substituting, I oftentimes think of sports. When in basketball, if a player gets tired, you sub them in. You need a substitution to get that player in. In football, there's a lot of injuries. If there are a lot of injuries, you're going to want to sub in a player for that other player. And so, I think a quarterback is oftentimes a spot, especially in professional sports, where you want a good backup to replace the quarterback that just might get injured. So what you want is you want two quarterbacks that are basically equal to each other. They're both very, 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 very good, so it doesn't matter which one you play because they are equal. In the same way, what you have here is x equaling a negative 2 minus 3y. And you also have an x right here. Those x's are the same. X and x, they equal each other. So that means at any time, if this x right here gets tired, that's all right, because we have this x that can substitute in for them. They are equal. They're the same player, basically. We're just going to substitute in different values. So if that's the case, if this x is tired, it's going to be 2 multiplied by x. And what does x equal? It equals this. So we're going to substitute that into here, and that's what substitution is. We're going to put what a letter equals in for the letter of the other equation. So this variable x equals a negative 2 minus 3y. I'm going to substitute that value in for the variable of my second equation. So it's going to be 2 times the quantity, a negative 2 minus 3y. This part right here just substituted in for that x. And then I subtract 3y equals 5. Now I only have one variable, class, and I could solve for that variable. So let's isolate y. Let's get y all by itself. Let's distribute first. 2 times the negative 2 is a negative 4. 2 times the negative 3y is a negative 6y. Minus 3y equals 5. So now I'm going to add 9. Combine like terms, a negative 6y and a negative 3y makes a negative 9y. That equals, I don't know why I added 4 here. Sorry about that. Add 4 here. And 4 plus 5 is 9. So what does y equal? Y equals the negative 1 when I divide by a negative 9. So I found what one of my variables is. I found what y is. Now I have to find what x is. So now I'm going to take this y value of a negative 1, and I could put that into this y, or I can put that into this y. It really doesn't matter because you're going to get the same x value regardless. So I'm just going to put it into this one. I know that x, maybe I should have at the bottom, x equals a negative 2 minus 3y. X equals a negative 2 minus 3y. And what did I say y was? A negative 1. So x equals a negative 2 minus 3 times y, and y is a negative 1. All right. I now simplify the right side, and I find what x equals. A negative 2, and then I have to multiply this. A negative 3 times a negative 1 is a positive 3. So x equals a negative 2 plus 3, so x equals 1. You found your y variable. You found your x variable. Now class, what I want you to do here when you write down your final answer is I want you to write it down in an xy ordered pair. What you found is you found the intersection point of both of these lines. Don't forget that. What you found is that intersection point on an xy coordinate grid. So let's write that down. Your x coordinate is 1. That comes first. Your y coordinate is a negative 1. That comes second. This is how I want you to answer all of the questions on the test. And there you have it, class. Once again, just like I said with graphing, you would be dumb, I shouldn't say dumb, you would be not smart to get any of these questions wrong because there's no need for it. You can always, always, always check your work. So I'm just going to do that really quick. This will be the last time I do that. All I'm saying is that 1 and negative 1 satisfy both of these equations. X equals a negative 2 minus 3y. X equals a negative 2 minus 3y. That is one of my equations. The other one is 2x minus 3y equals 5. 2x minus 3y equals 5. Now this point that I found to be my answer, 1, negative 1, has to satisfy both of the equations if I did it right. If I did not, if it does not, I've done something wrong. So we have x as being 1. That equals a negative 2 minus 3 times y, which is a negative 1. Let's see if this works out. 1 equals a negative 2 plus 3. So we get 1 equals 1. Ching, it checks. Let's make sure that my green one does now. 2 times x, which once again we said x is 1. Minus 3 times whatever y is, and y was a negative 1. That has to equal 5. 2 times 1 is 2. A negative 3 times a negative 1 is a positive 3. Does 2 plus 3 equal 5? Absolutely it does. This one checks as well. So now class, I know with confidence. I know I did this one right. I know it because I checked my work. I don't have to hope that this is right. I know for sure. 1, negative 1 is the right answer. All right, number 3. When we solve using substitution, we must get a variable all by itself. So what I think makes most sense, you have one of 4 options. You can get this one by itself, this one by itself, this one by itself, or this one by itself. It really doesn't matter. I would say it's easiest to get this all by itself because there's only one step. All you need to do is subtract the 3y. So that would make most sense, but it really doesn't matter. Whatever you decide to do is right as long as you do everything mathematically correct. xy in the first or xy in the second, it really doesn't matter. But for the sake of consistency, let's all get this variable x all by itself. So subtract 3y, subtract 3y. My second equation is now x equals a negative 3y minus 6. So here is your first equation. We didn't change anything. Here is your second equation. All right. This x right here has been doing a lot of work today, and it didn't get a whole lot of sleep last night, so it is tired. It needs something to come in for him to substitute. It is tired. So let's substitute this x, which equals a negative 3y minus 6, right in there. So we're going to have 2 multiplied by x, which x is a negative 3y minus 6. A negative 3y minus 6. That I still have this minus y. That equals a positive 9. All right, let's solve getting y all by itself. Distributing that to a negative 6y minus 12 minus y equals 19. 9. So now I have a negative 6y minus a y is a negative 7y. Add 12 to both sides. I get a 21. So when I divide by a negative 7, I get y to equal a negative 3. So I've successfully found my y variable. Now let's find our x variable. So I'm just going to put y back into here, and then I could find what x equals. So x equals a negative 3 times a negative 3 minus 6. So my answer, 9 minus 6 equals x. So x would then equal a positive 3. If you wanted to, you could put it back in here as well. You can put this negative 3 in for your y variable, just to prove to you that it doesn't make any difference. 2x minus a y, so minus a negative 3, that equals 9. So 2x minus a minus 3 is plus 3, that equals 9. So 2x equals, subtract 3, we get 6. Divide by 2, x equals 3, which is the same thing you got over here. So just to prove it to you, you don't have to do it 2 times, you just have to do one of them, but it doesn't matter which equation you choose. You can choose this one, or you can choose this one, it really doesn't matter. So your answer, your x is a 3, and your y is a negative 3. I invite you to check your work. I'm not going to take the time to do that right now, but you certainly can, and that way you can know for certain that you have the right answer. And that is solving systems of equations by substitution.